Let's say you're wanting to run your prized Lionel OO scale Hudson. So you get them ready to go, and you cycle the unit a couple of times to get them running in the forward direction. And after he's been highballing down the main line for a little while, you want to slow him down and ease him into a station stop. So you ease back on the throttle, slow him down, and you stop him right where you want him. And now, because you love the sights and the sounds and the smells of these old locomotives, you want to cycle the E-unit into neutral so you can see the headlights shine bright and hear the buzz of the E-unit. So you turn the voltage up, but this is what happens. It just starts going again. That's not what you expected and not what you wanted. You're not really sure what's happening, so you turn the voltage up a little bit more until that happens. The unit just cycled into neutral. Hey everyone, welcome back to Chris's Electric Train Lab. I'm Chris, and in this video we're going to be working on a Lionel 001 Hudson chassis. This one happens to be the 1939 to 1942 version, but what we're going to discuss applies to any Lionel 00 Hudson. And the problem with it is what you probably saw in the intro, is that the motor seems to start before the E-unit ever pulls in. And what I mean by pull in is the pawl gets attracted to the electromagnet, turning the ratchet wheel. So I don't have any actual specs on the motor or the E-unit in terms of starting voltage or pull-in voltage, but based on my experience, the starting voltage of these motors is probably about 6 to 7 volts when they are on the track pulling a train. If you noticed in the intro, this one actually starts running at about 5 volts, but that's probably because we are up on blocks and under essentially no load. And the E-unit is pulling in at about 9 volts pretty consistently, but that's clearly much higher than the starting voltage of the motor and higher than what I think the pull-in voltage should be of these. So I thought it would be interesting to run some baseline performance tests on this chassis before we make any adjustments to the E-unit. So for these tests I'm using my Lionel 1033 90-watt transformer, my trusty Fluke DMM, and it's basically just measuring the voltage from the transformer to the chassis. And what we're going to do is we're going to get it running, and we're going to raise the voltage up to about 9 volts. Then we'll cycle the E-unit a couple of times and just make some observations about how the E-unit performs. We'll drop it down to 8 volts, do the same thing, then 7 and 6 volts, and see what happens. So here we go. So there's about 9 volts. We'll go ahead and use the direction handle to cycle the E-unit. So one thing I'm noticing here is that when the E-unit drops out, the pawl drops very quickly, but when it picks up, it's a little bit slower on the pickup. Watch. Just dropped out very quickly. Pulls in just a little bit slower. But at 9 volts, it seems pretty good. Let's drop it down to 8. Cycle the unit again. And right there, we can already see, here's part of the problem. We're not picking up. If I give it just a little nudge, it'll pull in. It did it on its own that time. Kind of stuck again. A little nudge there. Yep. And again, he's kind of stuck there. Seems like he's getting stuck when he's changing to either the forward or reverse direction. Now right there, it looks like he went into neutral, but the E-unit didn't actually sequence. I think we're having a bit of a contact problem with the contact fingers to the contact board. Give it just a little nudge there. There we go, we dropped into neutral. So he's about half and half on 8 volts. Drop it down to 7. we go. You can see he's doing the same thing again. You give him just a little nudge, that's all it needs to pull in. Another little nudge. He's very slow there. And even if you kind of jog him a little bit, you can actually see the pawl getting pulled in just a little bit. But there's not enough strength there from that electromagnet at this voltage to pull him in like that. He did it on his own that time. So let's drop him down to 6 for the last test. 6 volts. And more of the same. Give him a little nudge. Is he gonna do it? Not quite. There we go. So, I think that's our test data for now. Through a little bit of additional testing and investigation, I've noticed a couple more things about the E-unit. The first, I think I mentioned before, this pawl has a very smooth and quick dropout, but when I pull it in manually, I feel quite a bit of resistance there. If I lift up on that arm and try it again, all that resistance has gone away, which leads me to the ratchet wheel. And when I spin the ratchet wheel manually, I can feel a lot of resistance to turning there, more than my experience tells me there should be. And what that typically is are the contact fingers on the back of the ratchet wheel providing too much tension or force against the contact board. And so I need to loosen up on the tension of those contact fingers. Another thing I've noticed is that each tooth on this ratchet wheel has like a little tiny divot and a kind of a wear mark if you look at it from that direction. And what I think that's from is a tiny little burr on the end of that hook. I can just barely feel it. I think just a couple of swipes with the file will take care of that. So here's where I'm at with the chassis. I gave everything a once over. Everything looked really good. I did a little bit of extra cleaning. What I've done with the unit this far is I hit all the little pivot points on the pawl with a little bit of isopropyl alcohol that I have in a aerosol spray can with the little red straw. And just to blow out any gunk or oil grease that might be in there, I have sometimes had to resort to a toothbrush if there's some stubborn gunk in there. I also cleaned off the burr on the end of the pawl and hit all the little divots that caused with a little bit of 1500 grit sandpaper to smooth out any burrs that might be there. I also removed the ratchet wheel and cleaned up the contacts on the ratchet wheel and the contact board. When I went to reassemble it, one thing I noticed that I kind of knew about, this is a customer's chassis and they clued me in on this issue. Typically this screw threads into this contact board, and once you get it threaded in and where you want it, then you use the nut to tighten down and kind of lock it into place. The reason why I think you can do that is that by loosening or tightening this screw, you can, in or out, you can adjust the distance of the ratchet wheel from the contact board. That distance can adjust the pressure of the contact fingers on the contact board, and that has quite a bit to do with the original problem we're seeing of the E-unit not being able to cycle down at the lower voltages. Hey guys, I wanted to bring you in for kind of an exciting point in this repair. I was just able to repair the threads in the contact board. This is the original screw. You can probably see that I've kind of polished it. It is a 3/48 thread, little helical threaded inserts. This happens to be one I got from a kit called Easy Coil, It comes with 10 of the threaded inserts, the installation tool, and the tap. And the part number, if you ever want it, is, if we can get it in focus, EK20110. And it is a what they call a 1D length. That's important. That is the length of the insert, and that's about the same thickness as the contact board. What you do is you need a number 36 drill. You just drill and then tap. Then you use the installation tool to thread the insert into the hole. Because I wasn't real sure how this would drill, I actually stepped up in the drill bits until I got to the number 36 size, and then tapping it was pretty simple, and doing the installation was pretty easy. So let me show you real quick how this works, since we got it kind of in the open. This is a little difficult to do, but we'll get it. So you want to get it lined up there. Thread it in. I didn't go all the way in. I don't know, you're probably not going to be able to tell, but there is a little bit of a gap there. Then I take my nut, and I like to start it by hand first. There we go. And then I just use a nut driver, give it just a tiny little twist there, and I can now feel that that screw is in there really stable, and I should be able to adjust it in and out to basically whatever length I need. So the threads are now fixed, probably just as good, if not better, than what the factory did. Alright, I've got everything reassembled, and it's time to start the sort of fine-tuning process. So let me show you how that works. I'm going to go ahead and get them started. And we're going to, for comparison's sake, we're going to run them at about 7 volts and try the E unit. And right now I have the screw screwed all the way in, and we can see the ratchet wheel is a little slow, or the ratchet wheel and pawl is a little slow. So what I'm going to do, disconnect my power real quick, and I am going to loosen the nut on the back. I am going to loosen the screw about 1/8 of a turn. Tighten the nut back down, not real tight, but just tight enough. Get my power going again. Get them back to about 7 volts for comparison. And that didn't really make too much of a difference. So, disconnect power again, and we'll try again. Loosen the nut. I'm going to go a 1/4 of a turn this time. And I'm kind of keeping track of where the slot for the screwdriver is. That's how I know about how far I'm turning it out. Another thing I just forgot to mention is that sometimes I'll use these styrene strips to kind of give me an idea, like a feeler gauge, how far out I am. This is a 40 thousandths, and I can put it in. This is a 60 thousandths, and he doesn't really want to go in, so I'm somewhere between 40 and 60 thousandths. So there we go, 7 volts again. Still kind of slow, but a little bit of an improvement. But let's keep trying here. I'm going to loosen the nut, and a lot of times I would go just 1/8 of a turn, but I know I'm not quite there, so we're going to go another 1/4 of a turn and see where we're at. So we see some improvement there. Still a little slow. We'll go, say, one more 1/4 of a turn out. And we'll see what happens. So back to 7 volts. So the E unit is cycling. It's actually cycling fairly nicely, but the motor itself isn't actually turning. And so what happens sometimes when you get that far out with the screw, a couple of things can happen. One, the ratchet wheel can contact the back of this arm, or the back of the pawl can contact sort of the front of the ratchet wheel, which both contribute to some turning resistance. Or what I think just happened here, we've gone out far enough that my fingers are no longer making contact with the contact board. So this is an indication that I need to pull the ratchet wheel back off, decide if I want to extend the fingers a little bit more or pull them in a little bit. This is a very trial and error process. It's going to take some time and patience to get it done just right. But there's one other thing I wanted to sort of demonstrate to you. Let's get it back to, say, there. There we go. So there's reverse. There is neutral. There's forward, neutral, and right there should be reverse. But the motor isn't turning. A lot of times what the problem is that the contact fingers on the back of the ratchet wheel aren't touching the contacts when this happens. And you can see that the contact fingers can be up or down, or they can be, left or right. If you look down at your ratchet wheel, I can see that my contacts are up and down, in the up and down position. To figure out which one might be causing me a problem, I take a little metal picks and I use a jumper lead, connect them together, and if I connect one lead to the back of one contact, the other side to the other contact, in this case nothing happens. But if I find this contact right here and this one, he starts turning in reverse. So what that tells me is that one of these fingers isn't touching. In this particular case, what I've noticed is if I manually move the ratchet wheel just a little bit this direction, sometimes, and he's not doing it now, but sometimes he would start turning. And when he starts turning, I can usually see some arcs or sparks on the lower contact finger. And so when I take the ratchet wheel off, that's the contact finger I'm going to focus on a little bit. So you can keep track of which one it is. I like to use a little silver Sharpie marker, and I'll put a mark on the contact finger or near the contact finger that I want to be paying attention to. So once you've determined which set of contacts isn't making contact when you run into a situation where you should be moving or in forward or reverse but it's not, by back probing, there's another technique I use to determine which of these contact fingers might be the one that's causing you the problem. So let's get it going. There's forward, neutral, reverse, neutral, second forward, neutral, and that should be our second reverse. Now we already know when we're looking at the drum that it's, or the ratchet wheel, that it's this side of the contact fingers that are causing us a problem. Hopefully you can see this. There is a contact finger right there. Now if I move the drum just slightly, hopefully you'll be able to see this. There's a little bit of arcing there, and when the arcing happens, the motor starts turning. When I look down at that E unit, I can tell that the contact finger that's arcing is the one on the bottom. That arcing is indicating a bad connection, and it's making and breaking that connection, and as it's doing that, it's creating those arcs. So I know it's on the bottom, so if I cycle the E unit here, that was the top contact finger, right there is the bottom one, and I've already marked it with my silver Sharpie so that when I pull the drum off, I know which contact finger to focus on. Wanted to show you guys real quick how I adjust and check the contact fingers. Right now I'm using a piece of 40 thousandths thick styrene. There's nothing magical about the 40 thousandths, it's just at the moment a good reference for me. And what I do is I just slide it under the contact fingers, or if I want it a little bit lower, maybe it's bumping in, it's just a reference point for me. If I want the contact fingers lower, I'll just press down on it and again check my work. If I want it a little bit higher, I'll grab the end and gently pull up and then go back and check my work. As I said before, this is a completely trial and error kind of process, so back to work. Okay, so here's where I'm at right now with this chassis. I have adjusted all the contact fingers, and the way I set those is that if the contact finger looks like this and it attaches to the ratchet wheel here, it comes up, has a little peak, and then it kind of rolls off. My 40 thousandths styrene just barely touches that edge, and when it's underneath the peak is probably at about 45 to 50 thousandths of an inch high. Off of the surface of the ratchet wheel. That's just kind of the magic number for this unit. It's going to vary for others. The cause of when the E unit would cycle into reverse but the motor wouldn't start turning was one of those fingers was sort of misshapen and seemed to have a little bit of damage. It may have been because it was arcing on the contact and had a little bit of pitting. So I was able to lightly smooth that pitting and kind of reshape that finger as well, and that solved the problem of it not always cycling into reverse. For the pivot screw, I have it turned out about a quarter of a turn. Much more than that, I would start to see arcing between the contact fingers and the contacts on the contact board. That's a bad sign. It means it's a bad connection, and you don't want that. I did add a little bit of powdered graphite between the ratchet wheel and the pivot screw, as well as between the pawl mechanism and the brass of the E unit frame. That's really a loose fit, and I was just looking for that last little bit of reduced friction to see if I could improve things just that much more. One other thing that this particular E unit wanted that I haven't seen before is that it wanted a little bit of a little tiny shim between the E unit frame and the locomotive frame under this screw here. There's something about if you tightened it all the way down, it's like the frame would bind the pawl mechanism just a little bit. And again, I'm looking for little tiny changes and improvements. So, moment of truth, let's see how well it does. There we go, so there's forward at 9 volts, neutral, reverse, neutral, second forward, neutral, second reverse, neutral, and back forward. There's 8 volts, neutral, reverse, neutral, second forward, neutral, second reverse, neutral, back forward. So 7 volts, neutral, reverse, neutral, second forward, neutral, second reverse, neutral, back to forward. Alright, so 6 volts is pushing it for this particular unit. If it doesn't work at 6 volts, we'll raise the voltage up a little bit to about 6.2 or 6.3, where it's much more reliable. Neutral, reverse, neutral, forward, neutral, reverse, neutral, and back to forward. So not quite perfect at 6 volts, but it's almost there. I'm probably going to leave well enough alone, but I'm going to continue with a little bit of testing. Alright, I think I have adjusted and tweaked this little chassis to the extent to which I can. All I have with is the chassis, but I wanted to try it in a more practical test. So I had an extra boiler, and I just added a train to it, and I wanted to see how it works in a practical way. So here we go. So he seems to be working pretty well. So back to the original problem. If you're running your prized Lionel OO scale Hudson, and he's highballing down the main line and you want to pull him into a station stop, you ease the throttle down, get him right where you want him, and you stop him. And you want to cycle him into neutral. So, there we go. Cycled into neutral. So I think that's it for this chassis. Thanks for coming along on the journey. Thanks for watching, and have a great day.